The Americas, two vast continents stretching from the icy Arctic to the tip of South America, have been home to diverse cultures for millennia. These lands, rich in natural beauty and resources, have witnessed the rise and fall of countless civilizations. Yet, the story of how humans first arrived in this part of the world remains a captivating puzzle, one that continues to intrigue scientists and historians alike. When did the first footsteps mark the soil of the Americas? Was it tens of thousands of years ago or even earlier? Where did these pioneers come from and what epic journeys did they undertake to reach these new lands? Did they cross icy land bridges or navigate treacherous coastal routes? These questions have fueled the imaginations of explorers, archaeologists, and historians for centuries, driving them to uncover the secrets of our past. The quest to understand the first Americans is a journey through time, piecing together fragments of evidence scattered across the continents. Each artifact, each site, tells a part of the story. We delve into ancient campsites, analyze the DNA of modern and ancient peoples, and trace the ebb and flow of glaciers over millennia. These scientific endeavors help us reconstruct the past. Each discovery brings us closer to unveiling the mysteries of the past, shedding light on the ancestors of those who thrived in the Americas long before recorded history. These findings connect us to our shared human heritage. The story of the first Americans is not a simple one. It is a complex narrative woven from many threads. It wasn't a single migration event, but rather a complex tapestry of movements, adaptations, and cultural exchanges that span thousands of years. By exploring the prevailing theories, examining the archaeological evidence, and delving into the genetic makeup of indigenous populations, we can begin to piece together a clearer picture of how these first pioneers made the Americas their home. This multidisciplinary approach is key to understanding our past. This journey of discovery takes us back to a time when the world looked vastly different, a time of massive ice sheets and roaming megafauna. It was a world of challenges and opportunities. It is a story of human resilience, ingenuity, and the enduring power of migration to shape the course of history. The legacy of these early pioneers continues to influence us today. Imagine a time when the world map looked drastically different, a time when vast ice sheets covered much of the northern hemisphere. During the last ice age, massive glaciers covered much of the northern hemisphere, locking up vast amounts of water and causing sea levels to plummet, exposing land that had been hidden for millennia. This dramatic change created a land bridge known as Beringia, connecting what is now Siberia and Alaska, a crucial link between two continents. This wasn't a narrow strip of land, but a vast expanse of tundra, grasslands, and even forests, teeming with life, offering a rich and diverse environment. The Bering Land Bridge theory, the most widely accepted explanation for the peopling of the Americas, proposes that our ancestors crossed this frozen highway, driven by the pursuit of food and new hunting grounds, following the herds that sustained them. These were not casual travelers, but seasoned hunters accustomed to harsh environments and the challenges of survival, braving the elements with remarkable resilience. They followed herds of megafauna, such as mammoths and bison, across this land bridge, gradually moving eastward into a new and unknown world, a journey that would change the course of human history. The Bering Land Bridge wasn't a one-way street. It was a dynamic corridor of movement and exchange. Evidence suggests that people moved back and forth across this land connection for thousands of years, creating a rich tapestry of interaction and adaptation. It was a dynamic landscape, shaped by fluctuating climates and the movements of both animals and humans, constantly evolving and adapting. This back-and-forth movement contributed to a complex genetic and cultural exchange between Asia and the Americas, enriching the heritage of both regions. The Bering Land Bridge eventually disappeared beneath the waves as the glaciers melted and sea levels rose, erasing the physical link but not the legacy it left behind. But its legacy lives on in the genetic makeup and cultural traditions of indigenous peoples throughout the Americas, a testament to their enduring connection to this ancient highway. This frozen highway, once a lifeline for early migrants, stands as a testament to the power of climate change to shape human history, and the incredible journeys our ancestors undertook to populate the globe, a story of survival, adaptation, and exploration. While the Bering Land Bridge theory holds a prominent place in our understanding of early American settlement, it's not the only route on the map. Another fascinating theory that has gained traction among researchers is the coastal migration theory. The coastal migration theory proposes an alternative, and perhaps even earlier pathway into the Americas. This theory suggests that early humans might have traveled along the Pacific coastline, navigating the rugged and icy shores. This theory suggests that intrepid seafarers journeyed along the Pacific coast, using boats to navigate the icy waters and establish settlements along the way. These early explorers would have relied heavily on their maritime skills to survive and thrive in such challenging environments. Proponents of the coastal migration theory point to several lines of evidence. They argue that the coastal route provided a more hospitable environment compared to the harsh interior landscapes. First, archaeological sites along the Pacific coast, some dating back thousands of years before the earliest known inland sites, suggest a maritime route of entry. These sites reveal the presence of ancient coastal settlements that predate inland discoveries. These coastal dwellers were skilled fishers and hunters, utilizing the abundant resources of the sea and establishing a unique way of life adapted to the Pacific shoreline. Their ability to exploit marine resources would have been crucial for their survival. Second, the distribution of some plant and animal species along the Pacific coast points to a pattern of movement that aligns with the coastal migration theory. These species, found in both ancient and modern contexts, suggest a continuity of human presence along the coast. These species may have been transported by humans traveling along the coast, providing further clues to early migration routes. The movement of these plants and animals indicates a well-established network of coastal travel and trade. Finally, linguistic and genetic studies reveal connections between indigenous populations along the Pacific coast of the Americas and groups in Asia and Oceania, suggesting a shared maritime heritage. These studies highlight the deep-rooted connections that span vast distances across the Pacific. These connections, while complex and still under investigation, add another layer to the story of early human movement and interaction. They provide a fascinating glimpse into the interconnectedness of ancient populations. The coastal migration theory doesn't negate the Bering Land Bridge theory. Instead, it complements it by offering an additional perspective on how early humans might have populated the Americas. It's possible, even probable, that multiple migration events, both by land and by sea, contributed to the peopling of the Americas. These combined routes paint a richer and more complex picture of human migration. The Pacific coast, with its rich resources and navigable waterways, offered a viable pathway for early explorers to venture into a new world, leaving their mark on the landscape and shaping the cultural tapestry of the Americas. This coastal route, with its abundant resources, would have been an attractive option for early settlers seeking new opportunities. In recent years, archaeologists have made some, groundbreaking discoveries. Evidence has surfaced that suggests humans arrived in the Americas far earlier than we once thought. These findings are, honestly, reshaping our understanding of ancient migration patterns. From stone tools to remnants of ancient campsites, each artifact tells a story of resilience and adaptability. It's fascinating to think about how these early settlers thrived in such diverse and challenging environments. This, my friends, is just the beginning of unraveling the rich tapestry of human history in the Americas. Genetic research has provided remarkable insights into the ancestry of the first Americans. By analyzing ancient DNA, scientists have traced the origins of these early settlers back to Siberia. The genetic evidence suggests a single migration event, followed by isolation and adaptation in the new environment. This genetic legacy continues to influence the diverse populations of the Americas today. The migration routes of early Americans were shaped by the geography and climate of the time. As the ice sheets receded, new pathways opened up, allowing groups to move southward. These routes were not just random, they were influenced by the availability of resources like water, food, and shelter. Understanding these routes helps us piece together the puzzle of human migration and settlement patterns. Adapting to the new world was no small feat for the early settlers. They had to learn to hunt new animals, gather different plants, and survive in varied climates. Over time, these groups developed unique cultural practices and technologies to thrive in their new environments. This adaptability was key to their survival and success across the vast landscapes of the Americas. The quest to understand early America is ongoing and ever-evolving. New discoveries and technologies continue to shed light on the lives of the first Americans. Each piece of evidence, whether it's a tool, a fossil, or a genetic marker, adds to our understanding of this complex history. The story of early America is far from complete, but with each discovery, we get a little closer to uncovering the full picture.